Hello and welcome to Console Cowboys. In the last video, we went over the Remix development environment and how to navigate the interface. So if you have not seen that video, please go back and watch it. In this video, we're going to use that interface to deploy our first smart contract. This will be a basic HelloWorld application to get you familiar with Solidity basics, compiling smart contracts, deploying smart contracts, and reviewing blockchain transactions. So in your web browser, open up remix.ethereum.org like we did in the last video, and let's get started. Once the development environment opens up in your browser, click Solidity, and then go to the File Explorer's icon. Click the plus sign and add in your file, HelloWorld.sol. So here's where we're going to write in all our code. This is our editor window. And I want to make it very, very clear that you need to type out all of the code as we're going through these examples in order to understand what the code's doing so that you can spot errors later on. This is crucial. So throughout this whole series, try to type out all of the code and really understand what it's doing before you even read the write-ups, especially when you're reading the blog. So the first thing that we're going to put into any program is going to be the progma solidity line. And all this is doing is it's saying, hey, we want to use compiler version 0.6.6, which matches up with our compiler over here, 0.6.6. If you found code on the internet you were trying to run and it's using a different compiler version, you can change it in there to run with the original one that it was intended for, or you can just paste it into the editor, compile it with whatever version you want, and then make adjustments based on the errors that you get, which is something you're going to have to do often as the compiler versions change all the time and there's little changes here and there. Now let's create our actual contract. We can easily do that with the contract keyword, followed by the name of our contract, and we'll enclose our contract within curly braces, because much like C++, we enclose things in curly braces and we end statements in semicolons within Solidity. We will also make use of a constructor. A constructor is only run one time when the actual smart contract is deployed. We're going to use a payable keyword here, which means that we can send value to this contract as an initial balance when it's actually deployed. And then if we want to make use of, say, comments to say what this constructor is doing, we can use // followed by our comment, much like any other language. Let's also create a function so we can create a transaction to view on the blockchain. We can do this with the function keyword, followed by the name of the function. And then let's make this function public so we can actually access it. And then now we'll use the pure keyword because we're not actually accessing any values or making any changes. So it's just a pure function. And then let's return a value. Let's have that value be a string, and let's have that value be in memory, since we don't need it to persist in storage. So in order to return this value, we're going to use the return keyword, and then we're just going to simply create a string to return. And then once this is actually returned, we can view the transaction on the blockchain. So let's do that next. So click the second tab down, which is our Solidity compiler, and ensure that your compiler version you're using, 0.6.6, matches what you put on the progma solidity line. So we're compiling with the correct compiler version. We're using the language of Solidity, and we're going to hit compile. If it compiles successfully, you're going to get this green check mark. If it shows you red or orange, you're going to have a warning or an error displayed down here. And on the associated line with the error or warning, you're going to have like a little dot here with some information on what you need to change. Also notice that when we deployed it, we got an ABI file and we got a bytecode file. If we click one of these, it'll copy to the clipboard and we'll show it right down here that we did that. Bytecode's the bytecode representation of this code that's deployed when the contract's deployed. And the ABI is the reference to the functions or the variables within our contract that we can actually talk to it with Web3, with our browser, or from the console. We'll take a look at all of that later when we're directly connecting to our contracts to attack them. And then if that's all working out correctly, head over to the third tab, which is where we deploy it. So we're going to deploy it within our browser in the JavaScript VM. We're going to use our first account here, which has 100 Ether currently. If we actually wanted to deploy the contract with a value, we can do that here, say 5 Ether, and that would be sent to the contract because we have a payable right here, and it will actually accept that value and have an initial value with the contract. And then we want to make sure that we are using the HelloWorld.sol here and hit deploy. Once this is deployed, you're going to see this deployed on the blockchain. We have a little green check mark, which means it works. And we have a transaction we can view down here, right? And we can see that we sent 5 Ether as our value right here. And if we want the address of the contract that was deployed, we can click that down here, and we can open this up, and we can see our function right here of hello. So if we click this, it'll actually execute that function. So let's do that. And we see another transaction popped up down here. If we open up that transaction and we take a look at the output, we'll see decoded output, and we'll see string hello world. That was our transaction on the blockchain. And there's also other stuff in here. So we have the cost of the transaction. So that was this gas value right here. And we have our from value, which is this BE6. And if we look up here, this is our account right here, this BE. And we have our transaction hash of our actual hash on the blockchain. So if this was an actual real blockchain, we could look up that hash on Etherscan and see all these values on there. Another thing we should take note of is that our account value is now 94.9. So it's 100 minus the 5 Ether we sent minus the gas value that we saw within the transaction. I hope learning about the basics of transactions and contracts was valuable for you. I know this is a very simple example of a smart contract, and while a Hello World application might seem simplistic and that we are starting off rather slow, this is important for your foundational knowledge because we actually covered a lot of ground. We created a full working contract structure. We covered some keywords you won't see in a standard application, for example, the keyword payable. The keyword payable is very important as financial transactions are built directly into the Ethereum blockchain. We also learned about constructors and functions and how constructors are only run the first time when the contract is deployed. We then compiled and deployed a contract, and we viewed an actual transaction for our blockchain interaction. In the next section, we'll go much more into depth with a more comprehensive smart contract example. We will code things like payments and authorization while exposing you to typical aspects of the Solidity language that you'll run across while reviewing smart contracts. At this point, you will be armed with everything you need to know at a basic level, and will begin learning about smart contract bugs and exploiting a wide range of vulnerabilities, while also learning more about other aspects of the Solidity language. If you do wish to go deeper between now and the next video, check out the references section within the blog associated with this video for your homework. As always, thank you for watching, and we'll catch you in the next video where we'll get a little bit deeper.